In this exercise, we're going to use EnviSat ASAR data to map oil spills. And we're going to take as our example the Gulf of Mexico oil spill from 2010. So let's have a look at the data first of all. Here I'm opening two EnviSat ASAR Y-swath mode images. So each one has a pixel spacing of 75 meters. And here we can see the acquisition dates. So if we go to the abstracted metadata, here we can find information about the product. We can see that the image was acquired while the satellite was ascending. We can see that the polarization is VV and the pixel spacing is 75 meters. Let's have a look at the data. If we expand the bands folder, we can look at the amplitude band, and here we can see quite clearly the extent of the oil spill. However, we would see it more clearly in the dB, in the decibel band. So if we create a new band for decibel, and then if we visualize that, then we can see more clearly the extent of the oil spill. And the other image we have is an archive image, in which there is no oil spill. And we'll see later on how we can use the archive image to better map the oil spill. So what we're going to do now is to process both the images in order to calibrate them, geometrically correct them, and mask out the land area. And given that we're going to apply various processing steps on both images, we're going to use the graph processing tool and the batch processing functions. So we go to Tools, Graph Builder, and here we will insert a list of functions. So if we right-click with the mouse button, here we can select the various functions we wish to apply. So first we will apply a calibration. And in the calibration, if we select the calibration tab here, we will select Save in dB. Then we will insert a multi-looking, and the multi-look factor we will select as 2. We're going to reduce the dimensions of the image by a factor of 2 in order to smooth out the speckle and also increase the speed of the processing. The next step will be to do the ellipsoid correction. The reason why we do an ellipsoid correction and not a terrain correction is because we're not interested in using a DEM and taking into account the terrain, because we're only interested in the sea area where there is very little terrain. So here we go to ellipsoid correction. Then finally we will apply a land sea mask. So we go to Raster, Masks, Land Sea Mask. And here we will select Mask Out the Land. So now we will connect these various processes together. So we will hover the mouse icon to the side of each process until the red triangle appears. Then we will click and drag the red triangle to the next processing step. So first it was calibration, then multi-looking, then ellipsoid correction, land sea mask, and then the final right output product. We can make these a little bit tidier by arranging them in a certain way to make it clear. Okay, now we will save this processing chain. We'll call it oil spill. and click on Save. Then we will close it. We'll close this window. And now, first we will delete this decibel band because we're going to batch process these images. So we go to Delete. In any case, we will have a decibel band in the final product. Then we go to Tools, Batch Processing, and we select Add Opened. And then here we will load our graph. And here we have our processing chain, which we will apply to these two images. Then here we will select our output folder, and then we will select Run. And here we have our final products open in the Product Explorer window. Okay, so we will close the input products in order to have only the output products. And let's have a look at them. So here we can see that the land has been masked out. The products have been geometrically corrected. Here we see the Gulf of Mexico with the land to the north. And we can see that the products have been calibrated and converted to decibel. We can see that by selecting Pixel Info and moving the mouse icon over the pixels, and we can see the values in decibel. Here we have our archive image processed in the same way. Now we will try to mask out the area covered by oil spill. And you may wonder why we do not use one image and just apply a simple threshold. If we look at the pixel values, you'll notice that there is a very clear difference between the area covered by sea and the area covered by oil spill. And the difference is, in this case, if we move the mouse icon over the oil spill and over the sea, you will see that over the oil spill we have decibels. We have decibels here, decibel values of around -22, -23 decibels, whereas over the sea we have -10, -11 decibels. So we have a difference of around 10 dB. So why not apply a simple threshold? Well, let's try it. We go to Raster, Bandmass, and here we select Threshold, a new band. Let's make the threshold 20, -20. And then we create an expression here, and we say mask out all pixels below -20. And we hope that the final product will be a mask of the oil spill. And we select OK, and we select OK. Now notice that while on one side of the image the mask has worked well, on the other side of the image it has completely ignored the area covered by oil spill. That's because we have quite a strong near to far range variation in pixel values. So if we again look at the pixel info, we looked only at this area. However, if we look at this area, the difference in dB is very different. So here we have, well, here we had values of around -20 dB, where we had oil spill. Here we have values of around -15, 16 dB. Okay, and if we go to this side, we'll again have a different value. So it's not sufficient to apply a simple threshold on just this one image. What we'll try to do is to compare this image with an archive image, where the near to far range variation is the same. And that way we can apply this, a similar threshold, but take into account the near to far range variation. So to do that, we will merge the archive and the crisis image together in order to be able to perform operations on the bands. So we will close these images in the viewer, and here we will remove this virtual band that we've just created. So we'll select delete. And then we go to radar, co-registration, stack tools, create stack. And here we will select add opened. And in the create stack tab, we will select product geolocation as the initial offset method, because we have not applied precise orbits to these products. And the product geolocation is accurate enough for the stacking that we would like to do. And then here we select an output file name, which we will rename, keeping only the common parts of both file names, and keeping the _stack suffix. And we will save that to our output folder and select run. Here we have our output stacked image. So let's check the registration between the two bands. So to do that, we will select one, and then we will go to the layer manager, and we'll overlay the other band, selecting image of band, and selecting the 2009 image, and then we click on finish. And here we can check the registration between the two products. What we should look at here is the coastline, because that should be the same, it should be identical for both images. And we can see that the registration is very good. There's no noticeable difference. Now we will try to mask out the area covered by oil spill, taking into account also the archive image. And what we will do is we will look at the difference in decibel between the two images. To do that, we will open the two images in two separate viewers in order to have them both open. Then we will go to Pixel Info. So we will go to View Tool Windows, Pixel Info. And then as we move the mouse icon over each image, we will see the values in decibel for both images. So let's go to the area covered by the image in which we see oil spill. And here, if we move the mouse icon over the image, we will see that over the sea, there is very little difference in decibel. Both images are more or less the same. Whereas over the oil spill, we have a much lower value for the crisis image, in which oil spill is present, and a much higher value over the archive image, in which there is no oil spill. Because the oil spill dampens the water surface, it becomes smoother, and we have a higher specular reflection. So we have a lower value in dB. We will exploit this difference to mask out these oil spill areas. And notice how the difference in dB is more or less the same from near to far range. So also here we have a difference of around 10 dB, and here we have a difference of around 10 dB. The difference in the pixel values are more or less the same. So what we will do is we will go to raster, bandmass, and here we will create an expression. We'll call it difference threshold. And here we will create our expression. However, we will not choose 10 as our threshold, because that's in most areas the maximum difference. So we'll choose a slightly lower value, but not too low to be too close to the zero. So first we will subtract the crisis image, sorry, the archive image from the crisis image, and we will set a threshold on the result of that. So let's say minus 6 dB, which is not quite minus 10 dB, but it's also not too close to zero. And then we select OK and OK. And here we have the areas of oil spill masked out. However, notice how the result is quite noisy. You have many pixels here classified as oil spill, when in fact they're more likely to be speckle, or due to the difference in backscatter caused by the waves. And if we look at the archive image, and if we zoom in, we can see quite a high variation of high to low backscatter, probably due to the waves and due to speckle. So we will try to remove that. And one way of doing that is to apply a smoothing filter on this archive image. So to do that, we right-click on the band in the Product Explorer window, and here we select Filtered Band. And what we'll do here is to create our own filtered band, and we will specify this filter here. Okay, we will create a kernel size of, let's say, 23 by 23 pixels, so quite a large kernel, and we will remove all of the filled pixels by left-clicking and dragging the mouse icon over the filter pixels. And here in the filter properties, we will select the type of filter we wish to apply, and we will apply a mean filter. So here we're going to apply a very heavy smoothing using a kernel size of 23 by 23 pixels, and here we will apply a mean filter. So we will mean all of the pixels in a 23 by 23 moving window across the image. And we will rename that mean 23 pixels. Mean 23 pixels. Okay, and then we close that. And then we select OK. And here we have our smoothed archive image. We will then apply that difference threshold again, but using this smoothed archive image. So we go to raster, we go to bandmass, and then here we will create another difference threshold band, but we will call it smooth. Okay, and here we edit expression, and we apply the same expression, so the 2010 image minus the smoothed 2009 image, less than minus 6 dB. And we will select OK and OK. And here we have a much clearer mask of the oil spill, the areas covered by oil spill. So now we no longer have some of these wrongly classified areas. Okay, we still have some points which may be due to waves or not due to oil spill, but in general we see quite clearly the area covered by oil spill. And we can compare this image with the crisis image. If we close all of the viewers and keep only the difference threshold and the oil spill image, we can see the difference. So what we will now try to do is to quantify the area covered by oil spill. So there are several ways we can do that. We could just go to the histogram and look at the number of pixels covered by oil spill. So the number of pixels with the value of 1 in the mask image. So here, having selected the refresh icon here, we can see we have calculated the histogram of this mask image, and we can see that there are pixels with a value of 0 and with a value of 1. The pixels with a value of 1 correspond to the oil spill. So if we zoom in to this part of the histogram, we can see the number of pixels with a value of 1. And knowing the dimensions of the pixels, which in this case are 150 meters by 150 meters, the original pixel spacing was 75 meters, but then we did a multi-looking, so we ended up with a pixel dimension of 150 by 150 meters. Knowing the pixel dimensions and knowing the number of pixels covered by oil spill, we can then estimate the area covered by oil spill. Now, pixel counting is quite a crude method of calculating an area affected by a certain phenomenon, but at least it gives us some idea, and it's a good quick estimate. Another way of counting the pixels is by applying a mask. So here, if we go to the mask manager, we select the function icon, and here we apply an expression. So we take our smoothed image and we select the pixels which are above 0. So these are all the pixels with a value of 1. And then if we go to Analysis, Statistics, we select the mask image, we select the mask that we've just created, and then we hit refresh. And here we see the number of pixels with a value of 1. So here we can do a quick calculation. So if we know that the pixel dimensions are 150 meters, and so in each pixel we have 150 square meters, and we multiply that by the number of pixels with a value of 1, which in this case, which is given here. So here we put in 1, 3, 5, 8, 7, 1, 0. So we put in this number. And here we get the extent of the area in square meters. Okay, so this is around 30,000 square kilometers. So here we have created a very quick estimate of the area covered by oil slick at this particular point in time, which we have calculated to be around 30,500 square kilometers. I hope it was interesting. Thank you for watching.